AI-generated code, the new supply chain risk no one is auditing. Today, we stand at the edge of a silent revolution, a revolution that is reshaping how the world writes software, how enterprises build products, and how attackers find the next weakness. This is episode 5 of AISec Intel. And in these next few minutes, I invite you to step into a world that is both exciting and frightening, because AI is no longer just assisting developers. AI is writing the world's software quietly, rapidly, invisibly. Yet, no one is auditing this new supply chain. No one is mapping where this code comes from, what it contains, or what vulnerabilities it silently spreads across global infrastructures. As we move through this journey together, I want you to imagine every line of code, every function, every API call, every dependency as a decision that impacts security, compliance, and trust. We will explore the hidden layers behind AI-generated code, the risks no one sees, and the defense strategies every CISO must master in 2025. Take a deep breath and let's begin. AI is writing the world's software. The landscape of software development has changed forever. 92% of Fortune 500 developers now use AI coding assistants. Let that sink in. Every merge request, every sprint, every release cycle is now influenced by AI. Half of all new code written today is AI generated, not peer reviewed, not fully traceable, not always secure. 3.2 billion lines of AI suggested code are deployed to production every single month. This is no longer an innovation trend. It is the new normal. Developers love the speed. Management loves the cost reduction. Enterprises love faster time to market. But hidden inside this acceleration are new vulnerabilities, new dependencies, new legal risks, and new attack surfaces spreading across your infrastructure. The problem is not AI writing code. The problem is AI writing code without governance, without accountability, and without any supply chain traceability. And today, you and I will unpack that risk, layer by layer. Why AI code is a supply chain risk. AI-generated code is not just code. It is a supply chain component. And just like any component, its origin matters, its integrity matters, its security matters. But here is the challenge: unknown origin. AI code is trained on oceans of undocumented data. We cannot trace which snippet came from which repository, which license, which vulnerability pattern, which insecure legacy library, unclear ownership. Who owns the generated code? You, the vendor, the open source creator whose code influenced the model. Today, even legal experts don't have a clear answer. Variable quality AI does not understand your context, your architecture, your threat model. It simply suggests what looks correct, even if it carries outdated logic, deprecated functions, or vulnerable patterns. These risks combine into one silent truth. AI code is the largest ungoverned supply chain entry point the world has ever seen. Real incident, the vulnerability cascade. Let me take you into a real story. A story that exposes the silent danger behind AI-generated code. A major fintech platform adopted AI coding assistants. Like many companies, they trusted AI to accelerate development. One day, the AI assistant generated an authentication function. It looked clean, professional, efficient. The developer, trusting the AI, merged it without a security review. But hidden inside that function was a subtle race condition vulnerability, something the AI had learned from outdated open source projects during training. Here's how the timeline unfolded. Day 1, AI suggested code merged. Day 14, vulnerability quietly deployed to production. Day 47, researchers discovered the weakness. Day 52, attackers exploited it. Over 127,000 customer tokens were stolen. The organization lost $4.2 million in remediation, fines, and trust damage. But the most painful discovery came later. The same vulnerability pattern existed in 200 plus other repositories generated by similar AI assistants. This is not just one weak function. It is an amplified weakness, multiplied across systems and industries, because AI learned it, copied it, and unknowingly propagated it. This is the vulnerability cascade. Hidden sources of AI code. To understand AI code risk, we must understand where AI learns from, because every suggestion, every function, every line of code your developers accept is shaped by the training data AI models are trained on. Public repositories, billions of lines from GitHub, GitLab, Bitbucket, including abandoned projects, insecure POCs, old student code, and repositories with known CVEs, technical documentation and forums, Stack Overflow answers, quick fixes, temporary patch workarounds, logic written for speed, not security. Legacy code bases from the 1990s and early 2000s, filled with outdated patterns, deprecated libraries, and insecure assumptions, unknown proprietary sources, scraped code, undisclosed datasets, opaque training mixes no one fully understands. This makes AI code fundamentally different from human written code. It carries the genetic fingerprints of thousands of unknown sources. It's some brilliant, some dangerous, some deeply vulnerable. And when you cannot trace the lineage, you cannot predict the security impact, which means AI generated code must be treated as untrusted input until it is validated, reviewed, and governed. Risk number one, vulnerability propagation. AI models learn from the world's code, all of it. Good code, bad code, insecure code, deprecated patterns, forgotten snippets, abandoned libraries. AI doesn't know which are dangerous. It only knows what looks statistically probable. And because AI generates code at scale, a single insecure pattern, a single legacy function, a single vulnerable snippet can spread across thousands of applications within weeks. Imagine one outdated SQL query pattern with unsafe string concatenation. If the AI model learned that pattern from its training data, it may recommend it across hundreds of developers, across dozens of teams, across multiple organizations, and suddenly your enterprise is at the center of a silent vulnerability wildfire. Some of the most common AI propagated vulnerabilities include SQL injection patterns quietly inherited from old code, XSS weaknesses due to missing sanitization, hard-coded secrets because I saw them in public repos, buffer overflows learned from insecure C/C++ snippets, race conditions copied from outdated concurrency code, deprecated cryptography, MD5, SHA1, DES, because legacy code still exists in training sets. A study from NYU found something astonishing. 40% of AI-generated code samples contained at least one CWE top 25 vulnerability, not because AI intends harm, but because AI duplicates patterns it has seen without understanding the consequences. This is the new reality, a world where vulnerabilities are no longer created manually, they are manufactured at scale by AI systems. And the only way to defend against this is to introduce governance, oversight, and rigorous review. Risk number two, IP and licensing contamination. This next risk is subtle, complex, and legally dangerous. Risk number two, IP and licensing contamination. The code AI generates may look original, but its structure, logic, and patterns come from vast training data pools. And in those pools exist all kinds of licenses. GPL, AGPL, MIT, Apache, BSD, custom commercial licenses, and even copyrighted proprietary code. When AI models generate code similar to GPL licensed snippets, your organization may unknowingly inherit copyleft obligations, meaning your proprietary software could be required to be open sourced. If AI suggestions resemble copyrighted code, You may unknowingly violate copyright law. If patented algorithms are reproduced by the AI, you may step into a patent infringement risk. And the most dangerous scenario, if any proprietary code accidentally made its way into training data, AI could regenerate trade secrets, exposing confidential algorithms, internal patterns, or competitive knowledge. Today, lawsuits are already emerging against AI vendors, claiming unauthorized use of copyrighted code in training sets. The law is still catching up. Regulators are still debating, but your organization cannot wait because one small suggestion, one accepted AI snippet, one copy pasted function can trigger millions of dollars in legal exposure. AI generated code is not just a technical outcome, it is a legal asset and it must be governed like one. Risk number 3, hidden dependencies. Risk number 3 is one of the quietest and most dangerous: hidden dependencies. When developers accept AI suggestions, they often inherit libraries, packages, and imports. They didn't intentionally choose. AI might suggest a package, a helper library, an outdated dependency, a poorly maintained module, or even a typo-squatted package where attackers create malicious lookalike package names. And behind that one suggestion lies a web of transitive dependencies. A single AI-suggested library may pull in 10 subpackages, 40 nested dependencies, hundreds of files, and thousands of lines of code your team never reviewed. Many of these dependencies may be deprecated, abandoned, unpatched, or maintained by anonymous developers with unknown reputation. Traditional SBOM tools may not detect all this because the AI suggestions bypass conventional procurement or dependency governance. Your architecture becomes fragile because you don't know what's inside your dependency tree anymore. This is software supply chain fragility born from AI suggestions. The result? Your application becomes a stack of unknown components with unknown maintainers using unknown security practices, all running inside business critical applications. One AI suggestion can quietly reshape your entire dependency layer. This is why hidden dependencies must be treated as first class supply chain risks. Risk number 4, hallucinated code. Now we enter one of the most deceptive threats: hallucinated code. AI has a unique flaw. It can generate code that looks real, feels correct, compiles successfully, but is fundamentally fictional. AI may reference non-existent APIs, imaginary library names, incorrect parameter structures, fabricated functions, or security logic that appears valid but fails quietly. The most dangerous part: hallucinated code often passes initial review because it looks professional. A developer might think this must be a new API update, or I guess this function exists in the new version, or the AI probably knows a better syntax. And this is exactly how hallucinations slip into production. They may compile, they may execute, but their logic is flawed or incomplete or insecure. Imagine an authentication check that always returns true because the AI stitched together logic from mismatched training examples. Imagine an API call with missing validation because the AI invented a shortcut or a security function that references a library that never existed, forcing developers to improvise insecure workarounds. Hallucinations are dangerous because they create a false sense of correctness, a subtle illusion that blinds both developers and reviewers. AI can write code that sounds confident but is structurally unsound. And this is why hallucinated code must be treated like a high-risk defect. Risk number 5, data leakage in suggestions. And now we arrive at one of the most alarming risks of AI-generated code: data leakage. AI models trained on public repositories have absorbed millions of secrets because developers across the world have accidentally committed AWS keys, private API tokens, database passwords, JWT secrets, SSH keys, internal IP ranges, Customer data patterns, hard-coded credentials. When AI regurgitates these patterns, developers may unknowingly introduce live or realistic secrets into production code. Imagine a developer accepting an AI suggestion containing password equals admin123 or AWS underscore secret key equals AKIA dot 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 dot
The danger is not just accidental leaks, but the habit formation AI creates. Developers begin trusting the AI. They stop questioning suggestions. They accept flawed patterns. They allow secret-like structures into production code.
AI suggestions must always be treated as untrusted, unvalidated, potentially contaminated. Never trust a credential-like pattern from AI. Never trust a connection string. Never trust an API token. Never trust a hard-coded secret. AI doesn't know what is sensitive, it only knows what it has seen, and much of what it has seen was leaked code. This is why AI-generated suggestions must undergo the same scrutiny as third-party contributors, because one accepted secret, one leaked token, one exposed database password can trigger an immediate breach. The message is simple. AI suggestions are powerful, but they must be validated like hostile input. ISO 42001, Mapping for AI Code Risk. Now, let's shift from the risks to the frameworks that help us bring order, structure, and governance to this new world. ISO 42001:2023, the world's first international standard for AI management systems, gives us a blueprint. It helps transform AI-generated code from an uncontrolled threat into a governed, traceable, and auditable asset. Let's walk through the key domains. 1. AI System Inventory 6.2.2. This is the first foundational pillar. You cannot secure what you cannot see, so organizations must maintain a complete inventory of every AI coding assistant being used, their model versions, training transparency, where they operate, which teams rely on them. This is visibility, and visibility is power. 2. Risk Assessment 6.3. ISO 42001 requires structured AI risk assessments, not just security risks, but licensing risks, confidentiality risks, and operational risks created by AI-generated code. Every AI suggestion must be seen as a potential risk vector. 3. Data Governance 7.3. This is critical. Organizations must define what data AI tools can access and what data is prohibited. No customer data, no regulated data, no trade secrets, no source code that cannot leave the enterprise. 4. Human Oversight 7.5. AI cannot be left unsupervised. ISO mandates mandatory human review, clear approval authority, and structured oversight on what goes into production. 5. Monitoring and Measurement 9.1. This is the heartbeat of governance. AI-generated code must be continuously monitored. Vulnerability rates, dependency risks, error patterns, hallucination frequency, quality scores, incident correlations. ISO 42001 does something powerful. It gives leaders a structured governance lens, a way to take something as unpredictable as AI-generated code and bring it under the discipline of a management system. This is how organizations move from chaos to clarity. NIST AI RMF, Govern and Protect now. Let's bring in another cornerstone of modern AI governance, the NIST AI Risk Management Framework, where ISO 42001 gives structure, NIST AI RMF gives action. It focuses on two major functions relevant to AI-generated code: govern and protect. Let's start with govern. Govern 1.1, legal and regulatory requirements. This ensures AI-generated code complies with licensing, copyright, and export controls. Nothing enters production without legal alignment. Govern 2.1, accountability structures. Who reviews AI-generated code? Who approves it? Who responds if AI-written code is exploited? Roles must be defined before something goes wrong. Govern 3.1, policies for acceptable use. Where can AI tools be used? Where are they prohibited? This prevents shadow AI in high-risk systems. Govern 4.1, risk tolerance, thresholds. Organizations must define risk appetite. Critical systems may allow zero AI-generated code. Non-critical areas may allow guided use. Govern 5.1, diversity of training data. This reduces biased or harmful code suggestions. Now, the protect function, map 1.1, inventory of AI systems, same as ISO, visibility first. Measure 2.3, evaluation of AI-generated code. AI-generated code must be scanned, analyzed, reviewed, and benchmarked before integration. Manage 1.1, secure configuration of AI tools. This ensures AI assistants run in hardened, restricted modes with limited access. Manage 2.3, incident response for AI code. There must be dedicated playbooks for AI-related vulnerabilities. Manage 4.1, SBOM, and lineage tracking. Every AI-generated component must be recorded, so vulnerabilities can be traced back to individual model versions. Together, ISO 42001 plus NIST AI RMF give us a powerful, holistic, internationally recognized governance foundation. This is how executives move from trusting AI suggestions to auditing, verifying, and governing them. Defense number one, AI code review layer. Now we enter the practical defense strategies. Defense number one is the AI code review layer. This is where organizations shift from reactive to proactive. Let's walk through the 5 key components. 1. Tag AI-generated code. Developers must label all AI-generated segments. A simple comment, an annotation, a version control tag. This creates traceability. When a vulnerability emerges, you know exactly which code came from AI. 2. Dedicated review queue. AI-assisted code must go through a separate pull request workflow, not merged directly, reviewed with enhanced security scrutiny, approved by senior developers or security engineers. 3. AI-specific security checklist. Traditional code review is not enough. Reviewers must check authentication logic, input validation, cryptographic functions, dependency risks, hallucination indicators, race condition vectors, unsafe patterns. AI often repeats. This builds a defensive mindset. 4. Attribution requirements. We must document which tool generated the code, which model version, when the suggestion was produced, how often similar patterns appear. This enables rapid incident response. 5. Verification testing. AI-generated code needs deeper testing. Unit tests, negative tests, fuzz tests, security tests, especially for edge cases AI often mishandles. This defense layer turns AI-generated code from an invisible risk into a manageable, traceable supply chain artifact. We are not stopping developers from using AI. We are surrounding AI with governance and oversight. Defense number 2, SaaS-DAST in the pipeline. Defense number 2 is essential because automated scanning is the only way to keep up with AI speed. We enhance our CI/CD pipeline with upgraded SAST and DAST capabilities. Let's understand how. Enhanced SAST for AI code. We configure static analysis tools to detect patterns. AI often introduces hard-coded credentials, insecure deserialization, outdated crypto, unsafe SQL concatenation, hallucinated documentation, deprecated function calls, unusual code shapes. These rules catch what AI tends to repeat. We also integrate ML-based anomaly detection to identify structures that don't match human development patterns, DAST runtime testing. We test AI written code live. Authentication flows must be validated. Authorization logic must be stressed. Input sanitization must be challenged. API calls must be verified against hallucinations. Enhanced SAST catches up to 89% of AI code issues. Automated scanning creates 3 times faster response cycles. But the key insight is this. AI writes code at machine speed. You cannot protect that code with human speed. You need machine speed security to match machine speed development. Defense number 3. Software composition analysis, or SCA. When AI suggests a library, a dependency, a helper package, you must assume it has not been security vetted. SCA helps you uncover hidden risks. Here's how. Automated dependency scanning. Every commit triggers a full scan of AI-suggested dependencies, deprecated libraries, vulnerable versions, malicious packages, typo-squatted names. The goal is early detection. Before merge, license compatibility analysis. AI may suggest GPL, AGPL, or other restrictive licenses. SCA checks whether the license aligns with company policy and blocks incompatible suggestions. Transitive dependency mapping. AI-suggested libraries often pull dozens of hidden dependencies. SCA maps the entire tree, revealing the real attack surface. Maintainer reputation scoring. Who maintains this package? Are they active? Do they patch vulnerabilities? Are they anonymous? This determines long-term risk. SBOM generation and tracking. for every project. We generate a software bill of materials. This SBOM highlights all AI-suggested components so we can trace vulnerabilities back to their source. This defense creates transparency in a world where AI coding assistants operate like black boxes. With SCA, we regain control. Defense number 4, secure coding guardrails. In this next defense layer, we move closer to the developer's workstation, where AI suggestions first appear, where trust is silently built, and where vulnerabilities can be stopped at the very moment of creation. Defense number 4, secure coding guardrails. These are not just technical controls. They are protective boundaries, invisible safety nets that ensure AI cannot introduce unsafe patterns without resistance. Let's walk through the two major pillars. 1. IDE and editor integration. This is where secure development begins. We deploy security-aware plugins directly into the developer environment. These plugins analyze AI suggestions before the developer accepts them. Real-time, instantaneous, frictionless. They can flag deprecated functions, identify dangerous patterns, warn about insecure logic, block hard-coded secrets, prevent unsafe APIs, highlight hallucinated code structures. Developers see red flags instantly. Before vulnerabilities reach the code base, we also configure AI coding assistants to run in secure mode, which filters risky patterns and reduces harmful suggestions. Pre-commit hooks add another layer. They perform security checks regardless of origin, human written, or AI generated. The result? Security becomes a continuous companion, not a final checkpoint. 2. Developer training. Technology alone is not enough. Developers must understand how AI thinks, how it fails, how it hallucinates, and how it propagates insecure patterns. So we train them on secure coding guidelines tailored for AI-generated code, common AI vulnerabilities, examples of flawed suggestions, recognition of hallucinated APIs, analyzing risks in auto-generated logic, validating cryptography recommendations, reviewing external dependencies suggested by AI. We even conduct phishing-style exercises where developers receive intentionally flawed AI code to test awareness. Finally, we create a culture of AI code buddies where junior AI-heavy users pair with senior security-minded team members to validate suggestions. The golden rule remains unchanged. Never blindly accept AI-generated code. Understand it, question it, test it, then decide. Guardrails protect your developers from the speed and the unpredictability of AI-generated code. Defense number 5, model-aware dev policies. This next defense expands beyond tools and testing and enters the world of governance, leadership, and accountability. Defense number 5 is model-aware development policies. AI assistants are now part of the enterprise ecosystem. And like any enterprise technology, they must be managed, governed, and audited. Let's break this down. 1. Approved AI tools. Registry-only vetted AI assistants may be used. We maintain an enterprise-wide catalog, approved versions, configuration hardening, usage context, risk ratings, vendor security posture. This eliminates shadow AI and prevents developers from using unknown or insecure tools. 2. Context-based usage policies. Not all AI tools are meant for all code. We define where AI can be used, allowed for internal utilities, restricted for customer-facing components, prohibited for regulated applications, banned for security-critical code. This ensures AI is used where risk is manageable. 3. Data exposure controls. We strictly define what data developers may share with AI services. No customer data, no regulated information, no confidential algorithms, no internal architectural secrets. This closes the data leakage channel that many organizations overlook. 4. Vendor risk assessment. AI vendors must be evaluated like any third-party dependency. We assess their data handling, training data sourcing, logging practices, breach history, indemnification clauses, incident response maturity. This provides legal and operational protection. 5. Incident response procedures. we create AI-specific playbooks. What happens if AI code spreads a vulnerability? Licensing contamination is detected, hallucinated logic fails in production, model updates change behavior. These scenarios must have predefined responses. Model-aware policies transform AI coding assistance from uncontrolled wildcards into governed enterprise tools with clear accountability and boundaries. CISO AI Code Audit Framework. Now, let's bring everything together into one unified lifecycle-wide enterprise framework. This is the CISO AI Code Audit Framework, a complete model for securing AI-generated code from the moment an AI suggestion is made to the moment it runs in production. We break it into 4 phases. 1. Pre-development phase. This is the planning and governance stage. We approve AI tools, define acceptable risk levels, configure security guardrails, brief the development team, communicate policies, set expectations. This creates clarity before any line of code is written. 2. Development phase. This is the execution stage. We tag AI-generated code, route it through enhanced review workflows, run SAST and DAST scans, validate licensing compliance, test every AI-generated dependency, verify authentication logic, check input validation, document attribution. This phase ensures every AI contribution is traced, tested, and secured. 3. Pre-production phase. Before deployment, we harden and validate. We conduct penetration tests, generate a complete SBOM, analyze dependency risks, confirm licensing compatibility, verify that all AI code passed mandatory review, ensure hallucination checks are complete. This is the final gatekeeping stage. 4. Production phase. This is the monitoring and resilience stage. We track vulnerability disclosures, monitor SBOM components, watch for model-influenced behavior changes, periodically reassess AI-generated code, maintain AI-specific incident response readiness, detect regression or drift in AI code patterns. This completes the lifecycle. Through these 4 phases, AI-generated code evolves from being an invisible risk to a governed supply chain component with end-to-end accountability. This is how CISOs regain control in an AI-driven development world. Day 5. Deliverable AI Code Audit Checklist. This slide represents your most actionable asset, the AI Code Audit Checklist. This checklist turns everything we've discussed into a practical, real-world, ready-to-implement framework. Inside the checklist, you will find pre-development governance templates, tool approval forms, risk rating worksheets, developer awareness checklists, AI code review checklist, tailored to detect unsafe patterns, hallucinations, logic flaws, dependency risks, outdated crypto, hard-coded secrets, race conditions, insecure validation flows, SAST DAST configuration, guides rule sets specifically for AI-generated patterns, SCA and licensing audit procedures to detect GPL contamination and uncover hidden dependencies, training modules for developers, how to think securely in an AI-assisted coding environment, governance templates, AI acceptable use policy, AI oversight models, incident response scripts, real-world case studies, actual incidents. With lessons learned you can apply immediately. This checklist is not theoretical. It is built for CISOs, security architects, DevSecOps leaders, compliance teams, and engineering directors who need immediately deployable frameworks. This is your Day 5 outcome, your operational blueprint for securing AI-generated code. Join the AISec Intel community. And now, as we conclude today's session, I invite you into a global movement. AISec Intel is not just a series. It is a community, a tribe of modern cybersecurity leaders who understand that the future of security is the future of AI. When you join the AISec Intel community, you gain daily AI security intelligence delivered directly to your inbox, actionable, insightful, always ahead of threats. WhatsApp community access, Connect with 2,000 plus CISOs, architects, and AI risk professionals, real conversations, real incidents, real solutions, 30-minute daily AISec Intel episodes, a complete evolving library of AI threats, defenses, use cases, and frameworks. Tools and templates checklists, SBOM frameworks, governance decks, everything you need to secure AI systems in a real-world enterprise. This is more than knowledge. It is a force multiplier for your cybersecurity leadership identity. And tomorrow, Ter, we continue with day 6. Prompt injection at scale, defending LLM applications. Until then, stay alert, stay aware, and stay ahead. Your journey into AI security leadership has only just begun.